In this lesson, we're going to start looking at what's called a compound inequality. Now, a compound inequality is like a compound word. A compound word is just a word that's made out of two smaller words. A compound inequality is just basically two inequalities that have been put together. And so a compound inequality is going to look something like this. It's going to say maybe 6 is less than x, which is less than 10, which basically just means that x is a number that's bigger than 6 and less than 10. So it could be 7, it could be 8, it could be 9, it could be 8.2. There's an infinite number of numbers in between there, but that's a compound inequality. We've got two inequalities going on, basically telling us that x has to be in between two numbers. And so the rule for a compound inequality, it's kind of two rules, but the first rule is that x has to be in the middle, or the variable has to be in the middle. And when you solve it, you work on both edges. And you'll see what I mean by that here in just a second. Okay, so we got to keep the variable in the middle, and then we're going to work on both edges as we go to solve these compound inequalities. Okay, so here's our first inequality. 4 is less than or equal to x plus 10, which is less than 20. So this has basically two edges to it, or two sides to it. Okay, there's two inequalities here. There's two inequality signs. Okay, so we're going to solve this just like we would have solved it if there was only one inequality sign. Okay, so let's cover this up for just a second. What would you do to solve that inequality? Well, you would subtract 10. So we're going to minus 10 here. And so when we do that, the x is going to come straight down. 20 minus 10 is 10. We didn't change the inequality sign, so it stays the exact same as what it did before. Now, what we just did over here to solve this inequality, that's what we want to do over here on this side as well. So we want to subtract 10 from the 4 as well. 4 minus 10 is negative 6. And again, that inequality sign comes right straight down. And so our answer here, kind of get rid of the lines there, would be negative 6 less than x less than 10. And so we kept our x in the middle, and whatever we did on one edge, we did on the other edge. Okay, we worked on both edges. All right, so let's look at number 2 as another example of that. Again, we have a compound inequality. We have two different inequality signs here. So whatever we do to solve one inequality, we're going to do to solve the other inequality. And so again, if you're having trouble figuring out, keeping track of what's here, just look at this much right now. 5y is less than or equal to 15. What would you do to solve that inequality? Okay, you would divide by 5, and so we're going to divide 15 by 5. Since we're dividing 15 by 5, we want to do the same thing over here with the negative 5. We want to divide it by 5. Okay, so the y is going to come straight down. Okay, negative 5 divided by 5 is negative 1. 15 divided by 5 is 3. And we didn't multiply or divide by a negative, so these inequality signs come right straight down just like before. So negative 1 less than or equal to y less than or equal to 3. Now we can get to where we have more than just one step going on here in the middle, but it's going to be that same process. Whatever we do on one edge, we have to do on the other edge, and that's going to be the key to solving these inequalities. Okay, so here's an example of a two-step inequality that we would solve. Okay, so again, we've got two different edges here, and so if we just look at this part of it, think about what you would do to solve that. What would your first step be? Okay, we would add 15. So we're going to put plus 15. And whatever we do on one edge, we've got to do it on the other edge too. So put plus 15 over here. Okay, so 3 and 15 is 18. 9 and 15, that's 24. The 6x comes right down, and those inequality signs come right down. Okay, then what would you do? Well, you would divide by 6. So divide by 6, divide by 6. The x comes down. 24 divided by 6 is 4. 18 divided by 6 is 3. So 3 is less than x. X is less than 4. And so that would be the answer to this compound inequality. All right, so number 4. Okay, try number 4 on your own, and then we'll check your answer. Okay, so first thing you should have found is your two inequality signs here. And so we need to subtract 6 and subtract 6. And so 2x stays in the middle. 14 minus 6 is 8. Negative 18 minus 6 is negative 24. Okay, then you should have divided by 2. So divide by 2, divide by 2. Oh, forgot to put my inequality signs in there. Negative 24 divided by 2 is negative 12. X is in the middle. 8 divided by 2 is 4. And those inequality signs, we didn't multiply or divide by a negative, so they're still the same as what they were to start with. Negative 12 less than or equal to x less than or equal to 4. Okay, let's look here at number 5. Number 5, we have 15 is greater than or equal to x over negative 2 plus 3, which is greater than negative 9. So again, we want to think about solving this just like we would do it if there was only one inequality here. So if that was our own inequality, what would you do first? Okay, we should subtract 3 first because we have x divided by negative 2 plus 3, and so we would get rid of the plus 3 first. So we want to start by subtracting 3. So we did it on one side, on one edge. We want to do that same thing over here on the other edge. We want to subtract 3. Okay, so now let's see what we got. 15 minus 3 is 12. Okay, we didn't do anything with multiplying or dividing, so this just comes straight down. Okay, we got rid of this plus 3. So in the middle we just have x over negative 2. And then negative 9 minus 3 is negative 12. And again, that inequality sign stayed the same. Okay, now what would you do to solve the inequality x over negative 2 is greater than negative 12? Okay, you would multiply by negative 2. And so again, that's what we want to do here. We want to multiply by negative 2. And so we got to do that to both edges. So multiply this edge by negative 2, multiply this edge by negative 2. So in the middle, we're just going to be left with x. 12 times negative 2, that's negative 24. Negative 12 times negative 2 is positive 24. And here's an example of where we multiplied by a negative number. And so those inequality signs have to change directions. And so it was greater than or equal to, and it's going to become less than or equal to. This one was greater than, and so it's going to become less than. So negative 24 is less than or equal to x, which is less than 24. Okay, and as our last example here, what would your first step be to both edges on this one? Okay, since it's 3x minus 8 divided by 3, since that whole thing is divided by 3, the first thing you should do to both edge is you should multiply by 3. So 4 times 3 is 12. Okay, we've gotten rid of this divide by 3 in the middle. So that would make it 3x minus 8 now. And then 12 times 3 is 36. Okay, what would your next step be? All right, you should add 8. So plus 8 and plus 8. And so now that gets rid of this minus 8 that's in the middle. So now we just have a 3x in the middle. 12 plus 8 is 20. 36 plus 8 is 44. So 20 is less than 3x, which is less than 44. And then what would your last step be? Okay, you should divide by 3. So divide by 3. And so as we divide by 3, 20 divided by 3 doesn't come out even, so we're just going to leave it as a fraction, 20 over 3. Okay, in the middle we just have the x, and then 44 divided by 3, that doesn't come out even either, so we'll just leave it as the fraction, 44 over 3. So if those things don't come out even and they don't reduce, then just leave them as a fraction. And so our final answer there is 20 over 3 is less than x, which is less than 44 over 3. All right, so what we've done here is we've solved inequalities, which is really the same steps as we would do to solve just a regular inequality. It's just that since it's compound, you've got two inequalities that you're solving, and so you solve on both edges. But always make sure you leave the x in the middle and do your work on both sides.